Hello everybody and welcome to lesson 17 of the Scratch course. So just a quick reminder of the projects. These are the teams as we currently have them. Just a reminder that for the next few weeks we'll be dedicating a bit of time to working on the project in the class. Lesson 19 will be all project focus and lesson 20 will be the demonstration and the prize giving. We also just a reminder of the videos that we've put together to cover a couple of extra topics, how to do backgrounds, the join block, how to nest the join block to build up longer sentences, and just the exporting and importing of code, especially helpful if more than one of you is working on the same project and you want to work on separate scripts at the same time. You can just learn how to export your code so that you can import it into your main project file. Last time we looked at validating user input. Basically, when you ask somebody to enter a number equal to a sum, like 1 plus 1, you expect the answer 2, 3, 4, 5, and not Bob, Orange, Cat, Moon, like that. So just ways of ensuring that people enter a value that you want or expect, and not to accept nonsense values into your questions. And then using counters, how you use counters to keep track of things, to count up, so that you know when you've got 10 items or such things. So just how to use counters. Today's mission, we're going to finish off lists. There were one or two topics that we didn't cover when we looked at lists the first time. And then we're going to look at the encoder once again. Now you've got a bit more experience, you'll see how simple it is to just use two strings to write to encode and decode a string. Okay, so looking at the list commands, we covered most of them last time. The ones we didn't really cover was the ones I've highlighted there in red. The contains function. So does my list type, list, contain a certain value? And then it's just the show and the hide variable. The show and hide list, very much like show and hide variable. If you want to display it on your stage or not display it on your stage, you can control that through code. Okay. Here's a quick example of using the contains method. If you remember, the first time we looked at lists, we wrote the week list, so the days Monday through Sunday, and then you could have said if day list contains Friday, which would have been a true case, then you can say got it, Friday's in the list, otherwise sorry, Friday's not in the list. Okay, so if you wanted to check if you had all the days of the week in your list, a bit of code like this could do that for you. And just a reminder of, even though the contains function would tell you that it has it, it doesn't tell you where it is in your list. So once you know it's in your list, you can do that as a first check. Your second one would be to then repeat through your list. So this is an example of a list function. You would say set position to 1, being the first item in your list, and you would say repeat for the length of my fruit list, in this case length of 5. If item position of fruit equals target, so if item in position 1 of fruit equals whatever you send through, so let's pretend this one was banana. So if item 1 of fruit, which is orange, equals banana, then the stop script. Otherwise, at position bar 1, so we go position now becomes 2, you repeat saying does the item, second item list equal banana, no, try number 3, does item 3 of fruit banana equal banana, then yes, stop the script. Let's stop it. And we jump out of the script back into the code that called this particular function. So this is a very basic example that you could probably use everywhere of how to quickly find a position of any item within your list. Okay, but generally speaking, what you could probably put at the beginning is to say if contains your item equals false, then just set position to -1 and in script straight away, rather than looping through and wasting the computer's time looking for it. Okay, so now a quick exercise, or relatively quick exercise, called guess a lottery number. So in this particular example, what we're going to do is write a program which, first of all, stores 5 unique random numbers in a list, and those random numbers must be the numbers between 1 and 10. Unique meaning only one occurrence of, or only one of. So in your list of 5 numbers between 1 and 10, Number 1 would only appear once if it was in the list, 2 would only appear once, and so forth. Okay, so you couldn't have repeating number 2, so you couldn't have two 2's in the list, and such forth. Once you have populated your list with your 5 random numbers, you'll then ask the person to guess any one of those 5 numbers. If they get it right, then they say, okay, guess again, until such time as the person gets it wrong. And then when they get it wrong, the program then exits, and you then tell them how many they got right in a row. So try that for a few minutes, give it a go, pause the video, and once you're done you can come back and see how we solved it. Okay, so the first part was generating a unique list of numbers. Okay, so first of all we're just going to come in here and just delete all from our, we created a list called numbers, a list variable called numbers, and we're just clearing it. If you don't do this, and every time you run the program it'll just keep adding your numbers onto your list, so your list will just keep growing. So let's just make sure that you flush your list out before you start. Then there were a number of ways this could have been done, so that's just one way. No one way is correct. So that's just a way. You can just say repeat 5 times, because I want to have 5 numbers. Set number, so this is a variable, normal variable number, to pick a number between 1 and 10. And then it's going to say repeat until, so check that does the number, this one list numbers contain the number that I've just guessed here. If it does, then try again. Try guess another number. So it's going to go, it's going to say guess another number, so pick another number between 1 and 10. Come back out. Does my list contain that number? No. Okay, in that case it jumps out, adds my number to the numbers, and goes around for the second number. So it'll do this 5 times, give me 5 unique numbers. Like I said, there's a number of ways you could have done this. This is just one example. Okay. Once you have the 5 answers, you then ask somebody to guess them. Guess the number. Okay, so match is just a flag variable, which we're going to set to true as the starting value, and matches is the variable that counts how many times we guessed right in a row. So now we're going to repeat until match equals false. So coming in, match equals true, so it comes in, says guess one of the numbers. You're going to guess the number, and say if numbers, my list that we populated earlier, contains the answer I've typed in. So if I did guess the number right, I'm going to change matches, which is how many did I get right, by 1, so it's now number 1, and then come again. If I get it right, this will go to number 2, go up to 2, and so forth. Okay, if I get it wrong, it's going to set match to false. It'll come here, it'll say does match equal false, does false equals false? Yes. Then it's going to jump out and say you guessed 3 of the numbers. Okay, let's look at this example quickly on the fly. Okay, so let's start off. Guess what numbers? So I know it's 5 numbers between 1 and 10, so let's guess number 3. Oh, I was right. Let's guess number 6. You only guessed one of the numbers. So I only guessed one of the 5 numbers guessed. Okay, so let's cheat a bit here so we can just see what's actually happening in the background. We're going to go to our data variable. We're going to show our numbers. Let's just do this. Show our numbers. So let's guess one of the numbers. I'm going to guess number 8. Here. 8. Guess another one of the numbers. 5. Guess another one of the 7. Another one of the numbers. 4. And I'm going to guess wrong now. 6. No, 8. Ah, I went wrong somewhere earlier. You guessed 3 of the numbers. Okay, so that's basically how it works. Can anybody tell me what the problem with this particular code was? Let me show you. Okay, I'm just going to go and show these again. What happens if I keep entering the same number? 3, enter, 3, enter, 3, enter, 3, enter, 3, enter, 3, 3. Oh, I guessed 6 of the numbers, but there's only 5, and I guessed the same one many times. So this is a problem. This is a problem with my code. Look at the code again. You'll see that I don't check if your answer was previously used. So he's going to just keep on ticking up the matches until it doesn't match any of the numbers. So to improve of this code, I'm going to show you a separate example. So what I did in this case to prevent that from happening is I actually went and created a second list called guesses. So when it comes in here, I'm going to say ask a number, and if numbers contains an answer, so is the number in the original list? Yes. And if my guess is already the answer, meaning I've already guessed this one before, then I'm going to pretend you got the wrong number and I'm going to jump out. If the number I'm guessing is not in my guesses list, then I'm going to increment the matches by 1 and add the answer you just given to my guess list. This will prevent me from using the same number more than once. So let's see this guy in action. Okay, so let's just run him. We're going to highlight both of those. Okay, so now let's see what happens. So if I go, I'm going to guess number 2, enter. See, now he's remembering number 2. I'm going to go number 5, enter. I'm going to go 5. Let's try 5 again. Oh no, you can't reuse number 5 again, so you only guessed 2 of the numbers. Okay, so it's just a way of making sure that you don't get the same across. So just little things like this you must remember when writing your program. Okay. Now back to the encoder, and we're looking at version number 2. Okay, in class we gave an example of a paper version of the encoder, and we said let's try this whole thing manually. So I'm going to show you an example of what the paper encoders look like. Okay, so here's an example of one of the sheets that we handed out. So each sheet had a unique little icon at the top, smiley face. We then had the letters of the alphabet, A through Z, and a space. And next to each letter we had an alternative letter. Each person was asked to write down their message in scrambled letters and to hand it to the other person with the matching little picture, and they should decode it. So if we had to start off with, I would go with my. So the first letter of my is M. So I go M, and the letter I must write down is Z. Second letter of my is Y. What is not? B. Then space is O, and so forth until they've written the whole message. Then they'll give it to the other person, and that person got it. They would get the scrambled letters. They would come along and say, okay, the first letter of my message was Z. What is Z? Z maps to M. So I must write down letter M. Second one letter that was on the piece of paper was B. What does B map to? Y. Third letter was an O. Was that space? And they would carry with the message, my name is Bob. So this was the exercise that basically had to do in class manually to see how long-winded this was. And then we went back to the software version. So here's an example using one of the scripts. Message is high there. The letter H mapped to C. The letter I mapped to the space character. T mapped to 4, and so forth. And then when doing it backwards, C on the scrambled side was next to the letter H, space was next to the letter I, and you get the message back. Okay, so that's kind of how they did paper. Now we're going to watch the Scratch version, and this is the lazy and quick way. Okay, so the first thing you do is to find the opposite letter. So basically the exercise of finding the letter on the one side and finding its corresponding letter. So in this example, this function takes in 3 variables: a character, a source letter string, and an output letter string. So the source letter string, let's say when you're encoding, is the string on the left hand side of that list. So we've said it would be the alphabet letters, and the output would be the out string, which is where we want to get characters to go to, change to, would map to a string with letters in this order. Okay, so as we said before, so we passed the first letter, in the case was my name is Bob, first character would be Y, M, source letters is the alphabet, so you go all the way down to the M letter on the left side of the string, output mapped to, if we look again, to Z, and so forth. So basically what it comes along goes to position 0, repeat until the character I'm asking for is equal to the letter in the position of the in string. So it's sort of 0, so it would go, if this was the normal dictionary alphabet version string, it would go A, B, C, D, E until it got all the way to the letter M. So get the position of letter M, which I think is 13. So okay, so my letter was the 13th in the row, so let me set my output letter to the 13th letter of the outstring. So the 13th letter of the outstring was Z. And stop the script. So this function would have returned letter Z, having been passed in letter M with the normal alphabet and the scrambled alphabet in that variable. Okay, so all this function basically did was looked up which letter was opposite the letter on that list. This function, utilizing that get character function we just looked at, now does the whole sentence. So you can say, okay, so passing in the source list of letters and the output list of letters, set this is my message position to 0, set the output message to blank, and repeat until the message position, so the letter in my long way, so my name is Bob, so until the last character of the sentence my name is Bob is reached, your input message, keep going. So you can say change to the first position of my sentence, which is letter M for my name, get the character of the first letter, so pass letter M into the in string, which is in this example I'm doing now would be a normal alphabet, and my scrambled sentence. Set my outer message equal to my output message plus that letter. So because it starts with blank, the first would be the first letter Z. And so it keeps looping through this. So each letter in my message, it's passed into this function, finds the corresponding letter here, and adds it to my message string. And here's how we run it. So this is all the plumbing work. So when clicked, just set the size to 50. So the picture you'll see now when I run the example, I had a little image that's a bit too big, so I made it a bit smaller. Here's my alphabet, letters A through Z, but we also allowed for numbers and a couple of punctuation marks, and at the end there's a space, well actually there's the space character. And then we had a scrambled one, so very much like this list has been scrambled up, this is also just a scrambled list. And then forever we set the mode to blank, so basically we can say am I encoding or decoding, we'll store that in the mode variable, and then we're going to repeat until mode equals E or mode equals D, so data validation, ask am I encoding or decoding. So the program wants to know, am I encoding my message, am I taking a normal message and scrambling it up, or am I decoding it? Well, you better type in a scramble that message, and I'm going to put it back into normal English. Once you've answered this, it'll set mode to either the letters E or D. Remember, you can't put something else in there because I'm preventing you over there. Then you type in the message, be it the normal English message or the scrambled message, and we're just setting that input message variable to the word answer. So whatever you answered, we're putting it into here. If I'm encoding, then I'm going to map letters from the normal alphabet to the scrambled. If I said I'm decoding, then I'm going to take my scrambled sentence using these scrambled letters, and I'm going to map them to the correct alphabet letters to give me the right message. When I'm done, I'm going to save my message and then wait until the spacebar is pressed to start all over again. Okay, so that's basic. So let's see this guy in action. Okay, so here's this machine here is known as the Enigma machine, used in World War II by the Germans to scramble their messages. So the first thing, am I encoding or decoding? So let's put the letter Y. Didn't like that. Why? Because he wants E or D. E. What is the message? Okay. My name is Bob. Okay. And there is my scrambled message using all the scrambled letters. So I would pass this message on to somebody else, and they'll come along, pushing the spacebar. Am I encoding and decoding? Well, I want to decode because somebody gave me a scrambled message. And what was that message? They gave me NF41 question mark NX 4 space 7 4 ZB ZT. What did they tell me? My name is Bob. There you go. Now you notice there I've lost my capital letters. This is because Scratch cannot tell the difference between a big letter and a small letter, and that's why my sentences here didn't have any capital letters, because it can't tell the difference between a big A and a little a. So if you include the big A there through Z and you include the big A through Z here, it all went very wrong, because he looks for the first letter. So let's say you had a capital A, a small a here and a big A there, and this A mapped to question mark and the big A mapped to, let's say, number 5. I would put the letter 5 in here, but when it came back you wouldn't have mapped back to the correct number naturally in some other cases. So basically Scratch messed up when you try to have upper and bigger and smaller letters. So basically you can only use either all big or all small letters in both. Okay, that's the only reason why he came out in small letters. Okay, if you want to check for yourself, you can go and try and add a mix of big and small letters here and big and small letters here, and you will find your messages won't work too well. Okay, that's just an example once again of how we can just use string functions just to do this quick encoding. Okay, now it's time to work on the project. For those who are in class, got a bit of time to work on their project, a bit of advice from us. And just remember, you can learn more by sharing, so don't hold your ideas to yourself. If you want to work your project and one of the guys from the other group also wants to do something and he's not quite sure and he comes and asks you, don't hold back. This is a way of sharing ideas, sharing knowledge, and that's how it works in the big world when you're working in companies and on teams. You do share your knowledge across those teams so that everybody can benefit and everybody can be more productive in their programming. Homework, work on your project, check out lesson 16 from last week, check out this lesson, technically you are already, and the lesson pages on this PowerPoint presentation are on the website in PDF document format. Next lesson, we're going to, this current lesson 17 was the last one that covers theory. So next lesson we're going to repeat the spin the wheel quiz game, and we're also going to have a little test the masters section. So that's if you have any questions on how to do something, we will try and demonstrate a solution to that. It won't be how can I write an entire Puckman game. It might be something simple like how do I get this guy to move when only this part of this guy touches him, and so forth. So small examples of things you might be facing. So enjoy your week, and we'll see you next week.